Hello friends, today's topic is decision tree. And decision tree is a supervised learning technique that can be used for both classification and regression problems. But mostly it is preferred for solving classification problem, and it is a tree structured classifier where internal nodes represent the features of a dataset, branches represent the decision rules, and each leaf node represents the outcome. In a decision tree, there are two nodes which are decision node and leaf node. Decision nodes are used to make any decision and have multiple branches, whereas leaf nodes are the output of those decisions and do not contain any further branches. The decision or the test are performed on the basis of features of given dataset. It is a graphical representation for getting all the possible solution to a problem and decision based on given condition. It is also called a decision tree because similar to a tree, it starts with the root node which expands on further branches construct a tree-like structure. In order to build a tree, we use the CART algorithm, which stands for classification and regression tree algorithm. A decision tree simply asks a question, and based on the answer, yes or no, it is further split the tree into subtrees. So this is the diagram of this is a main decision node, and this is the decision node. This is a root node, and this is the subtree, and these are the leaf node, and decision node, and leaf node. Okay. Why use decision tree? There are various algorithms in machine learning, so choosing the best algorithm for the given data set and problems is the main point to remember while creating a machine learning model. Below model, there are two reasons for using the decision tree. Decision tree usually mimic human thinking ability while making a decision, so it is easy to understand. The logic behind the decision tree can be easily understood because it shows a tree-like structure. There are these are the terminologies where those these are the terminologies where we use in decision tree. First is root node. Root node is the form where the decision tree starts. It represents the entire data set, which further get divided into two or more homogeneous sets. Leaf node. Leaf nodes are the final output node, and the tree cannot be segregated further after getting a leaf node. Splitting. Splitting is the process of dividing the decision node or root node into subnodes according to the given condition. Branch oblique subtree, a tree formed by splitting the tree. Pruning. Pruning is the process of removing the unwanted branches from the tree. Parent child node. The root node of the tree is called the parent node and the other node are called the child node. How does the decision tree algorithm works? In the decision tree, for predicting the class of a given data set, the algorithm starts from the root node of the tree, and this algorithm compares the values of a root attribute with the record, real dataset attributes, and based on the comparison, the branch and jumps to the next node. The branch for the next node, the algorithm again compares the attribute value with the other subnodes and move further. It continues the process until it reaches the leaf node of the tree. So these are the steps to understood the algorithm. Step 1, begin the tree with root node, say S, which contains the complete data set. Step 2, find the best attribute in the data set using attribute selection measures, ASM. Step 3, divide the S into subsets that contain possible values for the best attributes. Step 4, generate the decision tree node which contains the best attribute. And step 5, recursively make new decision tree using the subset of the dataset created in step 3 and continue this process until a stage is reached where you cannot further classify the nodes and call the final node as a leaf node. This is the example of decision tree. Suppose there is a candidate who has a job offer and want to decide whether he should accept the offer or not. So to solve this problem, the decision tree starts with the root node, salary, attribute by SM. The salary is $50,000 to $80,000. And the root node is split further into the next decision node, further gets split into one decision node. This is a first is distance from the root node is split further into the next decision node. Okay, this is the office is near to home or not. If no, then decline the offer. If yes, then again split the root node. The next method gets split into one decision node. This is a cab facility or not. If cab facility, if not, then if no, then decline the offer. If yes, cab facility is available, then accept. Then again split into the decision node and okay. Then if cab facility, then yes or no, the accepted offer or declined offer. So finally, decision node split into two leaf nodes, accepted offers and declined offer. So this is the diagram of decision tree, example of decision tree. Attribute selection measures. While implementing a decision tree, the main issue arises that how to select the best attribute for the root node and for subnodes. So to solve such problem, there is a technique which is called attribute selection measure, ASM. By this measurement, we can easily select the best attribute for the nodes of the tree. There are two popular techniques for ASM, which are information gain and Gini index. Information gain is the measurement of changes in entropy after the segmentation of a dataset based on an attribute. It calculates how much information a feature provides us about a class. And according to the value of information gain, we split the node and build up decision tree. There is a formula of information gain equals to entropy S minus weight averages into entropy of each feature. Entropy is a metric to measure the impurity in a given attribute, and it specifies randomness in data. So entropy can be calculated as entropy S equals to P S log 2 P S minus probability of no into log 2 probability of no, where S is the total amount of samples and probability of yes, P no, probability of no. And Gini index is a measure of impurity or purity used while creating a decision tree in a cart classification and regression tree algorithm. An attribute with the low Gini index should preferred as compared to the high Gini index. It only creates binary splits, and the CART algorithm used the Gini index to create binary splits. Gini index can be calculated using the Blow formula. Gini index equals to 1 minus summation to j pj square. Thank you.